Welcome to Geometry for AP. Today's lesson we're going to talk about isosceles and equilateral triangles and some of their properties. Our essential understanding is that the sides and angles of isosceles and equilateral triangles have a special relationship, and we're going to learn what those are about and how to apply those into other figures. So first, let's go over the basic parts of an isosceles triangle. An isosceles triangle has its own vocabulary, so it's important that you know them. First, there is the vertex angle. The vertex angle is the angle that is created by the two legs of an isosceles triangle, and the legs are the two congruent sides. And then we have the base, which is the non-congruent side. And then we have the base angles. The base angles are the angles that are attached to the base. All right. And so the legs are congruent. The vertex angle is the angle created by the two legs, and the base is the third side. Make sure you draw this picture out, record this information, and we'll move on. All right, so first we have the isosceles triangle theorem. It says that if you have an isosceles triangle, triangle ABC here, and its two legs are congruent, then the two angles, the base angles, are congruent, or the two angles opposite of those two congruent sides are congruent. And then the converse of that says if you have the two base angles, then you know the sides opposite of those two angles are congruent. So make sure you highlight both these theorems. We're going to be applying this. So when you have the sides marked congruent, make sure you mark the angles congruent. When you have the angles congruent, make sure you mark the sides congruent that are opposite them. Theorem 4.5 is another isosceles triangle theorem. It says that if a line bisects the vertex angle of an isosceles triangle, so we have this line here, it's an angle bisector of an isosceles triangle. It says, then the line is also the perpendicular bisector of the base. So this is the first time we're looking at that perpendicular bisector word. Remember I told you there were three types of bisectors in the very beginning of the year? This is the third type. So if you have this, then you end up with a right angle here and a bisected base. And so you have a perpendicular bisector. It goes through the midpoint D. All right, so make sure you highlight that there. Have that picture in there. All right, so then we have two corollaries. Corollaries are just extensions from our theorems. There are other things that can be proven. And so what this one says, it says if you have an equilateral triangle, then all of the angles are congruent. And this one says if you have all the angles congruent, then you have all the sides congruent. So if a triangle is equilateral, then it's equiangular. If it's equiangular, then it's equilateral. So highlight those corollaries. They should be in that topic 4 section. And so then let's take these theorems and let's apply them with the triangle sum we learned before and some of the properties we have. So pause the video and try these, see how you do, and then turn the video on when you want to look and see what the results are. Okay, so when we look at this one, we have x and we have y. Okay, and so our y value will end up being 40, and our x value will end up being 80. I got this because if these two sides are congruent, then these angles are congruent. If these two sides are congruent, then these two angles are congruent. And so that if this is 50, and then a triangle has to add up to be 180. So that's x plus 100 equals 180. And so then x is equal to 80. For the y one, this is y and this is y, so that's 2y plus 100 equals 180, and so then 2y equals 80, y is equal to 40. All right, so here we have two congruent angles. So if this one's x, this one's x. All right, if these sides are congruent and these angles are congruent, then this is a perpendicular bisector. Remember that also, since these sides are congruent, these angles are also congruent. So that's 52, and that's 52. And so then if this is a right triangle, that means there's 90 degrees left minus 52. And so that leaves me 38. So x is equal to 38 degrees, and y is equal to 4. Actually, it's not 38 degrees, it's just 38. There's no degree symbol because these are variables, and we don't put units of measure on the variables. And so there are two values there. All right, so here we go. We got another practice. Practice this one. Practice this one. Put these into your notes. Make sure you work both of them. Find the value of x in each one. Okay, now that you have this one done, if you're not sure what the answer is, when you come to class, make sure you ask. Here we have another one. I want you to do this one. You may pause the video and work through this problem. If you have struggles with this one, make sure you ask when you come to class the next day so we can go over it. I'll give you a helpful hint here. Vertical angles are congruent, and that should help you get the information you need. All right, and that was the last example, so you'll have the problems due in class, and we will see you the next day.